Thank you for going through this training. My name is Ashish and I wanted to quickly introduce myself. Before I start further, I wanted to have a disclaimer here on the screen that I work for AWS, but the views which I am sharing are my own and they do not represent my employer. About me, I am passionate about technical training and empowering individuals and enterprises to learn technology in the simplest possible manner. I have been into industry for a long time and have been into various roles. I have worked as a authorized instructor for Microsoft, Cisco, VMware, and Veeam. I hold various technical certification from industry leading vendors. And so far I have trained 5,000 plus learner in various technology in a classroom learning. On personal front, I am a native of India. I worked in India and Dubai for a while and now I am based in London. Let's focus on the training now. You may be thinking there are so many AWS trainings available on Udemy. What makes this particular training unique? I'll give you not only one, but four reasons, and probably you would relate to all the things which I'm saying once you go through this particular training. First reason, I plan to keep this training in a classroom style. I don't want to just record a video and post it, but I want to keep it in a way that you will feel that you are sitting in a classroom and you are learning directly one to one from me. Second reason, you will learn technical concepts through a lot of simple analogies. Sometimes we get so lost in understanding technology that we do not relate technology to the real life or day-to-day scenarios. You would definitely enjoy making this connection by learning technology through simple analogies I would be using in this training. Third reason, in this training I will focus on why of the technology. Sometimes we are so focused in just knowing what and how. For example, what is a service, what is the configuration associated with this, what settings are available, etc. And we fail to understand the why behind the technology. Why somebody wants to use this technology, what business problem they are trying to solve, or what benefit this technology will bring to your business or your day-to-day work. So I would focus on that why component and not just what and how of the technology. Fourth reason, I would be combining multiple mediums to share knowledge. I would be using whiteboard, demos, and slides to effectively explain the concept and services. Some topics are well explained through demo directly. Some would require some understanding, so I may use slides. Sometimes I would be much better at explaining things through a whiteboard, so I would be using multiple medium to explain you the concept. I hope you would enjoy this training and will learn new things. I would also like to connect with you through LinkedIn. If you have any suggestions or feedback, please do reach out. Also check the last module of this training to know about the other resources which I have created to help learners in learning most about AWS Cloud. So enjoy, learn and share. Thank you for your time. Now we have a better understanding of how DynamoDB stores data. Let's also try to understand how that data is organized within that storage. Right? So we'll focus on partition key and sort key and see why we need it. So let me first explain why we need a partition key. I would use the same example of books. So this is my data which I want to store into a DynamoDB table. Now, I need to ensure that I have some way to uniquely identify an item which I am storing. So maybe if this is my table, I could think about two things. I could think about keeping author name as my unique attribute, or I could think of using this as a unique attribute, or maybe if I want to expand this or this. Let me give you what I would prefer in this particular case. See, this value is not available in all of the items I want to store. So this is not going to be solving the problem because I have to always have a partition key. I can't create an item which doesn't have a partition key. So these two values or even this third value is not a good candidate to be selected as a partition key. So I would brush them off. Hey, you will not be working for me as a partition key. Now let me focus on author and book title. Partition key, something which should give you unique way of identifying that particular item. Now, think about if I keep author J.K. Rowling as my partition key. What if J.K. Rowling comes up with more books? What if Leo Tolstoy has lot of collection of books? Now, I won't be distributing them evenly. It may happen, let's say J.K. Rowling has 5 books, R.K. Narayan has 10, Leo Tolstoy 50, this one has 1, John Milton has 100. So this would be creating something uneven balanced partitions for me. One partition may have 100 record, another may have 5, 10 or something different. So that may not be a very unique way of distributing or will not be generating unique values in a hash algorithm for me. So I would say let's not focus on author, let's go ahead with title. So yes, that can work. I could go ahead and create title or select title as my partition key. So I said, hey, title of the book, you are going to be my partition key. And this is what I selected is referred as a primary key. Primary key is the way by which we uniquely identify the item which we are storing into the table, and it is a mandatory attribute. I have to specify this information, right? So if I want to implement this solution, I could quickly go to my table here. I would go to DynamoDB console and I would create that table. So I'm going to DynamoDB in AWS Management Console and I want to implement this table here, which will be very easy. I'm coming to dashboard and here is a create table option. Once I create table, I could add values and that should not be a problem. So I'm creating a table here which says all books. Okay. Partition key, I want to say book title is going to be my partition key. With my partition key, I have to specify the type of data I would be using there. Is it going to be a binary number? Is it going to be a number? Or is it going to be a string? So in my case, this is going to be a string. Right. So if I want, I'm good to store this data. I could go ahead and just say create table and done. My table would be ready. I do not need to specify additional attribute as of now. If my requirement was very simple, I want to go with the default value selected for me by AWS. I'm okay with that. And I could just go ahead and say create table and my table is ready. Right. I could start adding items in that, should not be a problem at all. But is it a very efficient table I created? I would say probably not, and let me give you rationale behind it, why this may not be very efficient. Now DynamoDB takes little time to create things. It was creating and now it is active, so it is available for view shortly. Now it is available and I could insert items in that, no problem at all. But let me tell you why this is not very efficient. What if J.K. Rowling comes up with a second edition of Harry Potter, which has 15 chapters and the price for that edition is $25. You get the idea? Now, if I go to DynamoDB and say, hey, please insert this record, that would be treated by DynamoDB. Oh, looks like somebody wants to update Harry Potter information. So it would basically override this 12 with 15, override this 20 with 25, which I was not looking for. Why this happened? Because this time my title is not able to uniquely identify record, and that is not unique because this title is Harry Potter also. The difference is this is second edition and the previous entry I have is first edition, but I can't differentiate because I am just using a book title as a partition key, right? So challenge here is that I can't uniquely identify how to solve it. What if I come up with this type of design? What if with every book I go ahead and add extra attribute that I would be storing your edition information also? You get the point? So what happens now? This combination of Harry Potter first edition is unique. Combination of Harry Potter second edition, this is unique. So what I did here, I have combined these two attribute to form a key, and that is called my salt key and primary partition key. So partition key is still the same, and I have added additional attribute which we refer as a salt key, and as the name is salt, it would store my data in a sorted order of addition like this. So this time what I created, actually I created a primary key which is made up of two components within it. One is a partition key and one is a salt key, and this is also referred in documentation as a composite key. This is composite of two entities. One is your partition key and a salt key. Now one thing, you cannot create salt key after the table has got created. So if I go back to console and now I realize my mistake and now I want to add a salt key, no, that is not going to work. I have to recreate that table, right? So idea about DynamoDB is that you have to be very thorough with your design, or your data modeling exercise should be very strong when you are doing it. You need to understand a lot of use cases, the pattern your user would use to access your table, type of queries which will be handled, type of operation which would be happening, and only based on that you should design your table, because some of the attributes are not changeable afterwards. Right? One of that attribute is a salt key. So once I have created a table, I can't change its a partition key, I can't change its a salt key also. So we need to be very uh, understanding of the possible solutions or possible type of query or patterns or the data which my users would be storing in this table and how they would be utilizing this particular table, right? So if I go back to console and I go back to my all books table and say, hey, I want to perform something, I want to update settings, all right, let's go ahead, and here I have no option to make any changes on that. I could edit capacity, but I cannot change the partition key on that. So this is basically no use to me. So I would go ahead and delete this table and I would be recreating it. But this time I would be selecting a partition key plus salt key combination to store my data. Done, table gone. Let me create a table now. This table name is same, all books. Partition key which I want to keep here is my book title. I would keep it as a string, and here I am saying I want a addition, and that addition I could specify to be a number. That would make things unique and it will give me a better idea. So I would be able to search for this, and now I'm happy with it. I would go ahead with default. If you read this, salt key is optional. If you know your data is always going to be unique, you do not need a salt key. Right. But salt key will also help you when you run queries on this particular table. So design things properly, think on what the patterns are, and the data modeling is very important. You can find a lot of details about data modeling. It is beyond the scope of this particular module, but probably when I have time I would put a training on data modeling of DynamoDB. But right now let's focus on a very simple example here. I'm happy now and I would say create a table. Now this table is created, but it doesn't have any items inside. That makes sense because we just created it. So there is nothing inside. This table is into creation phase. In a minute or so, it would be ready. It is active. And if I need now, I could go ahead and add items on that. Right. Before I add item, let me give you a little more information on partition key. So partition key, we would expect it to be having something which is highly cardinal. these attributes that have distinct values for each item, like email ID, right? Check your surround, check your company email. Is two person having the same email address? Answer is no. Employee number, very unique. Customer ID, again a unique number. Session ID, order ID, these are all unique or distinct values we are utilizing. If you are using composite key, you can use composite attributes. Try to combine more than one attribute to form a unique key. Example I could give you, let's say I have two cameras, camera 1 and camera 2, and they all send me some image every 1 minute. Just give me an example. Every 1 minute they capture the image and send it to me. Send it to me in the sense my table. Now if I've created camera ID, which is camera number 1 and camera number 2 as a partition, what would happen? I would have record for or item for 1, and then there would be an image, then record from 2, and there would be image, right? After 1 minute, when I get another image, it would override the existing one, new image added, override the existing one, new image added. So this is not solving my purpose, right? What if in this table design I said, okay, I would have camera ID and I would add a timestamp also as my field. So this is my timestamp. I have added timestamp. So camera number 1, 10:05, a unique value. Camera number 1 again, 10:06, a unique value. So what I did here, I created a composite key. So you could combine things, like I combined here a ID and a timestamp. Same way you could have said, you could consider an order table where we have customer ID, product ID, country code as the partition key, and order underscore date as a sort key, which can be used to search for a specific order, a specific customer in an efficient manner. So data modeling is a very important aspect of a DynamoDB table. I hope you are getting the idea. So let me now go back to console and add some items here. So this is my books table. I'll go inside this books table. I can see some details here. I will talk about all the setting, capacity and all, but my books table is title is there, and my addition is a number, that is my sort key. And now I want to see the items inside. Currently there is nothing. What I could do, I could go ahead and say I want to create an item. All right, let's go ahead and do that. So I would give a book title. So this is my Harry Potter edition. Let's say I say first edition, right? And now I could add more information on that. Okay, so I can add a new attribute. Let's say I want to store author detail. So this is my key value. I have a key called author, and the value for that is J.K. Rowling's, right? I could have another attribute added. Maybe this is a number. This time it is going to be the chapters. Maybe chapters are, let's say, is 12, and sorry, and then I go ahead and say, okay, let me add another value, another attribute, sorry, which is a number and which is going to be the price. And let's say this is my $15 as a price, right? Done. And I have created an item. That is how easy it is. In real life, you won't be using this interface to create item. Probably you would have them coming from some system you have created, or maybe if you are bringing things from on-prem or from other databases, that is also possible. If you see here, there is an option which says import from S3. So those type of settings can also be done, which you can import huge bulk item to DynamoDB if the need be, right? So we just have added an item. Let me create one more item. Now let's say this time I want to add the second book we had is the guide. Now think about it. This is my design that I have said I would need a partition key and I would need a sort key. Is sort key mandatory? What do you think? Partition key is mandatory. I can't do without it, but I still create a record without the sort key. Let's see that. So addition sort key, its number is automatically coming to be 0, right? Invalid number, you must use ASCII number. If I'm not doing anything, it is considering 0 as a default, right? So I could go ahead with default, but I can't keep it blank because it is expected to be added. If I'm not specifying, the default value is coming to be 0, but let me create this one with the number 1, and I would then again add attributes here. See this? See the list of attributes? If you feel you want to add values like binary, Let's say I want to add a binary and call it here, is it having a Kindle edition or not? So that value I could put here, right? So this is base 64 encoded value which I have to put. So I would need that base 64 encoding, and then I should be able to add a binary number here. Right, so that is possible. Similarly, I could add different type of attributes here: string, null values, number set, binary set, list can be part of it, or a map can be part of it, which you can think like a nested attribute which may have multiple values within that. Like list could be, maybe I want to add person's children detail, that would be a list, right? Maybe I could create some map like a date of birth as a map. If you do not want to use this interface, there is one more option which says JSON view. So this is how also you could specify information. This may be more efficient if you are doing some copy pasting type of thing, or you could also see a much easier fashion of view DynamoDB JSON, and here you could keep on adding record. So maybe this time I want to add the chapters information on that, and in chapters I have to say 15. Now see one more thing. I have not specified here the data type. Data type can be picked up automatically by DynamoDB. So I've just specified this information, and now I say create an item. Let's see what was the error here. Chapter, sorry, this comma is missing here. So I have to add the comma, and I hope everything is fine now. And now I have created one more item here. So you decide what works well for you, and you can create these items inside. It should not be a problem at all. So you see that how easy it is to get started. I have just used default setting. In the next chapters, I would explain you the different settings available, how the capacity is decided, how to create different type of indexes. But hopefully this section is clear. I'll take a pause and we'll join back you into the next section. Thank you. Now we have a better understanding of partition key and sort key. Let's focus on secondary indexes now. Why we need it is more important. So we have to first understand why we need secondary indexes and in which cases I would be using them. I would say in most cases you would use them, and they have to be carefully selected, same like your partition key and sort key. I may want to re-emphasize here that whatever you want to achieve with DynamoDB, it will only work if you have done right data modeling. Data modeling is an exercise we will do initially before you actually implement the table, to understand the access pattern, to understand the type of data which will be coming in, to understand the query pattern which will be there, to understand the performance requirement, and based on that you would be creating a table. So it may require more planning than your traditional databases, but the benefit here is that I could scale it to virtually unlimited capacity in terms of storage and in performance, and I can get high durability plus a managed service, so I do not have to worry about the different aspect of server management or database management at all. But you have to be thorough with your design. Okay, so this is my table as of now. I have some I have some items. I have to remove this word record. I come from that RDBMS world, and that always comes to my mind. So why we need indexes? Let's first focus on that. Why is more important rather than what or how. So this is my table, which is having a composite key, primary key equal to partition key plus sort key. Partition key currently is a title, and sort key is the author. Let's say we selected that, so that is also possible. We didn't go for addition, and maybe we just said we would use sort key as the author. Hopefully this would be unique combination, I'm just hoping. But let's say now we start asking some questions to table, right? While we are storing data, maybe we have to process that data and understand some patterns, or understand or answer some queries. So question comes, which book has 18 chapters, right? Now let's consider that you have to answer this question now by looking at the table now. So you can directly go to this particular record and say, okay, you have 18 chapter. How you come to this? You checked where is the numbers. This is not a number. This is not a number. Numbers are here. Numbers are here. There is no number. So I scanned all the items here, and then I come to the result that, hey, this one has 18 chapter. This is not an efficient way of searching a database or a table. So what we are having here, that we created some of the indexes or the methods of query which is not efficient to answer a question like this. Which book has 18 chapter, it has to go through every item, every attribute, and then come back with a value that, hey, what is the value of book chapter? So this is not efficient. Or if I ask some rational questions like or relational question like, give me all the book of price less than $15. Again, not a very good design of my table. I can still answer it. I would tell you how to answer this question through database, but it is not a very efficient design. That's why we need to create indexes. And these indexes are referred as secondary indexes. So what is my primary index? My partition key is my primary index, and then based on my access pattern, based on my business requirement, based on the attribute which my customer would be searching a lot or my application would be searching a lot, I would be creating secondary indexes. Let me give one more example to bring home the point. What I have here is a DynamoDB table which I created, which name is geometry. In that table, I have selected my partition key as color. So any item which is coming up, based on their color, they should be stored in different partition, and they should be further sorted based on the shape we have. And let's say we have 3 partitions just for sake of understanding. And these are the items on my left, which I want to store here. And this here is the magic hash function who would perform the distribution of my items as they come into my table. So I insert records, insert items, and then this hash function would then read that, store it. So maybe all same color items are going into one partition because my partition key is color. So as you could see, all my items are stored same color item in the same partition, like here, black, red, blue, green. That's done. Now, there are chances that I may have multiple items of the same color like here, and these items are now sorted based on shape. So circle first, then triangle, then square, circle first, then triangle, and then square. Just an example, right? Hope you are getting the idea. So this is how my sort key is being used to store this item. Right? If I go ahead and ask some question to this database, hey, database table, give me how many purple color shapes we have. So my query is on a partition key or the primary index which we have. So that is good for DynamoDB because what it can do now, okay, what you want a purple color information. Color is my partition key, and I know that in first partition all my purple color items are there. So it has to only go here and not on other partition and give you the details of all the purple color shapes we have. Right? So efficient way because it knows where all purple color items are. I ask a second question. Give me details of purple color square. Right? So two things we have to look for. First is purple color, and then second, I am looking for information of a square. So this time also, I would go ahead, search everything, or DynamoDB would search in this partition and then use sort key of shape to identify the square and deliver me the details of it. No problem at all. Efficiently, I am getting the result. But I change my question now. I say, how many squares we have, right? Square is not my partition key. So DynamoDB can still answer this, but what it has to do, it has to go to every partition, every item, and ask, are you a square? This one would say no, 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 yes. So we have one square. This one, no, 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 yes, second square, third square. So it would still return me the result of 3, but it is not at all efficient. I have just few items here. What if we have multiple items and multiple attribute? It would very complex. It will be very complex way of going to every item and looking for the information. So we need an efficient way. So to summarize what we have here, current primary key is not efficient for the question I asked. That's where global secondary indexes comes into picture. So I'll now create something called a global secondary indexes. Before I go ahead, indexes are an additional way of performing efficient query or search or operation within my DynamoDB table. So we call them secondary indexes. Right. Secondary indexes are of two types. One is called global secondary index, and second one is called a local secondary index, right? I'll show you both of them. And local secondary index can only be created at table creation. So obviously I did a mistake. I have to delete that table again and I would recreate it, and that's why I'm saying that I have to be very thorough with my design. I may be sounding like a broken record, but I cannot emphasize enough how much is important to design your DynamoDB table efficiently. So that's why that table which I already have in my console won't work, but I will create another table and then I'll tell you how to utilize this local secondary indexing and global. And let's first talk about when to use which one. So let's say this is my table. The data is there, color is there, sort key, shape. Now I know that my questions are always coming for a shape. People say how many triangles we have, how many circles we have, how many squares we have. So let me create a global secondary index, and this time I would create a global secondary index and say, hey, you would be a global secondary index called shape. My primary key is this. My data is currently stored in the format of color, and that's there. When I say I want to create a GSI, short form is GSI for global secondary index, what happens behind the scene? Consider that a new table is created for you, and in that table your items are again rearranged, but this time this table's partition key would be shape. Hope you're getting the idea. So all the item which you currently have, consider that you got one more table created which is based on the GSI you specified, which is shape, and all these items would be then rearranged and stored into this GSI. And this time what will we seeing? We seeing all triangle in one partition, all circles in one partition, and all square into another partition, because my key was a shape. Hope you get the idea. Sort key is optional. I may say I don't need a sort key. If I wanted, here I could have said sort key is color. So they would be then arranged within that partition based on the color. So that depends on what I want. But GSI would be creating a separate table behind the scene, and you would be able to select that what would be the new partition key. Think like the same data has been rearranged for you in a pattern based on shape as a new partition key, right? Another thing which you could do, you could say, I may have an item here. Let's say this is my item, and then this is my item is my triangle. There is a color, let's say purple is the color of that. Maybe this was created in Dubai, and this was having a date creation of, let's say, of 18th of February, and this one was created by Ashish, something like that. I could say I would be not needing all the attribute in my GSI. I just need the attribute of shape and when this was created, that's all. So what we can do, we can project only the required attribute rather than storing the all attribute. So all these attribute would be stored into my main table. Main is not the official word, but to explain I am using it. So all my data, all the attribute of that item is stored. And when I said that my GSI would only have shape and date, so my shape would come and then date would be also created, whereas here I would have all this information. So you could project only the required attribute within your GSI. You do not need to carry all the attribute with your GSI. I hope this thing is clear. So let me go to console and we would then create this table, and I'll show you how we can create a GSI associated with that. So that table is there, all books, let it be. I would go ahead and create another table here and call it geometry. So my table is geometry. Partition key I am using here is color, which is a string. I am using sort key as a shape. Let's say this is also string, no problem at all. And now I have to deviate from the default setting. See this thing here? In default setting, there is no local secondary index created. there is no global secondary indexes created, right? This is also important. Can it be edited after creation? So GSI can be edited after creation also, no problem at all on that. But if you look at the top here, which says local secondary index, they cannot be edited after creation. I'll talk about them, but let me first focus on global secondary index. So I won't go with default. I would say I want to customize. Okay. All right. You want to customize. Fine. What you want to customize. So here are my option to create a secondary indexes. Let's read the information. Secondary index let you query the data in a table using an alternate key in addition to query against the table's primary key. So it is an alternate way of query. DynamoDB doesn't require that you use indexes, but they give you application more flexibility when querying your data. After you create a secondary index on a table, you can read data from the index in the same way as you do from the base table. So this is the main word, base table, and DynamoDB support two kind of indexes, global and local. Let's talk about global. Global index, an index with a different partition key than the one on the base table. A global secondary index can have a simple or composite primary key. Very complicated English. Let me explain it here in simple. I say I want to create a global index. Done. All right. If you see, this looks similar to what I had for my table creation. Think like you are creating another table, but the data wouldn't be inserted directly, but it would be come from your base table. So this time I say, okay, I want to have this only as a shape. And that's all. I could go ahead and say, this is my shape index, and maybe I could give it a name just to identify, which says GSI. So this is my shape index GSI, global secondary index based on shape. And if I feel okay, I could just say create index. Done. If I want to create more indexes, no problem at all. So this is my one index. I could go ahead and say I want to create another global index. Maybe my data would be searched mostly based on date. So I want to have it as a primary partition key, and I want to have a way to sort based on the city of that shape. So now I am creating a date city index, and again it is a GSI. So I just given a name to identify it. And here is the projection I was talking about. I could say I want to project all the attribute, which may not be efficient, unnecessarily creating a bigger GSI. Or I could say I only want keys to be projected, right? You know that we store data into a key and value format. So I could say only keys are required. I do not need values in that. Again, it depends on your use case. And you could say I want to include a specific attribute only. So I want to attribute, maybe add an attribute like date, city, and maybe the price, but nothing else beyond it. My actual item may have hundreds of attributes, but here I would have very specific attribute. So it is up to you what you want to include. That is purely your decision. For simplicity, I am keeping all, but you have to be designing this efficiently to have a better performance and utilization of your data. So I'm creating an index. So I have two indexes created. Now the difference is one index is only having a partition key. Another index has a partition key and sort key, and I can create up to 20 global secondary indexes. No problem at all on that. So GSI can be up to 20, right? Now, GSI are flexible because they can be created anytime. So let's say you tried your best to accommodate all the possible query patterns for your request, but none of the query pattern is matching to what your current requirements are. So that time you could go ahead, create a GSI, query the data if you need to, and then maybe delete that if you do not need it anymore. So that is giving you flexibility that you can add them anytime and remove them also should not be a problem at all. But local secondary indexes are a little different. Let me first explain a local secondary index, and then I'll come back here and create a local secondary index. Right. So global secondary index hopefully is clear. We are creating a different table altogether, and in that we are storing the required attribute which you selected. Let's focus on local. I expanded little more item details into my example now. So now I have circle created on 20th Feb in London, black circle created on 3rd October in Dubai, blue triangle 14th May in Prague. Done. Now I go ahead and say, hey, I want to query something. All right, let's go ahead and query. So we say query. I say how many purple color items for London. Now what I did, my table is having a partition key of color, sort key of shape. So I'm still making a request for a purple color item matching this. So DynamoDB would know that which partition to go and check the data. But now I asked for an attribute which is not indexed. So what it has to do? It has to go to all purple color item and say, are you from London? Are you from London? Are you from London? So this is not efficient design, right? In this case. Or I ask another question which says, give me details of purple color items on 18th March. Again, same thing. I would know where the purple color items are, but I have to still go to every item and check every attribute. This is not very efficient. Why it is happening? Because one single partition may have lots of items. So a single partition may have lots of items, and we need an efficient way to find specific item. That is where local secondary index is useful. So its name is local secondary index, LSI. So LSI is specific only to that partition, and that's why it is called local, right? It is giving you ability to search within the same partition or index data within the same partition, and that's why it is called a local secondary index, and this cannot be changed after table creation. So saying it again, you have to design properly what is going to be a local secondary index, and local secondary index would not have a partition key. It would use partition key of the table and then would add additional sort key of your choice. So that's what we would be creating here. So DynamoDB support two kind of indexes, GSI and LSI. GSI index with a partition key and sort key that can be different from those on the table we just saw. Local secondary index, an index that has the same partition key as the table but a different sort key, and it would make more sense when I show it to you in console. So I come here and say I want to create a local index, and see this, I am not seeing an option to use partition key. Only thing I can do is sort key, whereas if I cancel and show you global index, here I have option for partition key and sort key also, right? So hopefully this difference is clear to you. So I would go ahead and say I want to create a local index, and what would be then primary key here? What would be my partition key? It would be the same as of my table. So in my table, whatever I have created as my partition key, it would just add additional attribute to make it a LSI. A additional sort key will be created. So maybe I want to say it is going to be color, and sorry, color is already there, so I won't use that. I would just say here that it is going to be date. So what it will actually create for me, it will create for me a shape date index, not data, sorry, date. So shape date index is created for me, and this is my LSI. Again, I have a choice to project everything or project only few attributes from that item. So it is up to me. So I can create an index like this. I can create more indexes, local index again another one, and what would be that? Maybe this time I want to have it as a city, right? So this one is again, technically it is what? It is my color. Sorry, I made a mistake, I guess. So color city index, let me quickly check, sorry for that. So what was my, yeah, partition key was color. So let's correct this mistake right now. Even if I have not specified, only the name has to be changed. Actually, it is still using the same information. So I will just change the name. Technically, it is still using color as the primary key there. So I selected color, and then I am creating another local index here. And this time I am saying city is going to be this, and that will be my color city index, and I would call it a LSI, and done. Now I have created two local indexes and two global indexes, right? So hopefully this is clear. Why we need it is clear, and how to create it is also clear. you have to be very thorough in understanding differences between them. And if you are preparing for exam, there will be some question which will check your abilities on these understanding of local or global indexes, right? So global index, when you query, the queries will run across all partition because the name says global. Whereas local, they would be used to query data within a single partition. That completely makes sense. Global secondary index have no size limitation, right? Because they are global and it is DynamoDB global size, so it is no limitation in terms of size. Local secondary index cannot exceed 10 GB. Why is that? Because the partitions which we create, it cannot go beyond 10 GB. And if it is stored within partition, itself cannot go beyond 10 GB. So that is a limitation on a local secondary index. Also, when I am creating a global secondary index, basically I would have a base table, right? And I would have a GSI created for me, which is also a separate table. And what I can do, I could say base table, you would be requiring 100 reads and 200 write performance. But my GSI, you do not need that much of performance. I will give you 20 read performance and 50 write performance. I'll explain read write performance, but just consider that the throughput or performance setting you are configuring, it can be different for base table and it can be different for your global secondary index, because technically they are two different indexes having similar data, but technically they can both have their own separate provision throughput. Should not be a problem at all. Whereas if I'm talking about the local secondary index here, local secondary index would share the throughput of the table, right? So if you have a partition created and that has some throughput, as this reside inside the partition, it won't have its separate provision throughput. It would utilize whatever is configured on the table level, right? Hope this thing is clear. Read consistency, only eventual. What I mean by that, this is my base table, right? Sorry, clear this and draw this again. Let me use a black color. This was much efficiently looking here. So this is my base table. And once I commit something to base table, then it would start reflecting into my GSI, which means if I made the change right now, eventually it would be reflecting here also. And that's why my read are always eventual, which means I may still get stale data, right? But in case of local, as it is still stored on the same partition, it can be strong or it can be eventual. You decide based on the parameter you specify in the get item, and you would get either strong or eventual, purely decided by you. But in case of global secondary index, it is always going to be a eventual consistency. GSI can be more, 20. Now, if you think that what about after 20, I would say then you are designing things wrongly. I've seen a lot of use cases where people use a lot of indexes, but I still have to find some design where we need more than 20 indexes. If you're doing that, if you're trying to treat your DynamoDB as a SQL database, then you are doing something fundamentally wrong. So 20 is a good enough number. It doesn't mean you need to have that many. And as it is dynamic, because these can be created anytime, deleted anytime, you may create indexes temporarily and maybe then later you delete it, but 20 is a good enough number, right? So this gives you flexibility for the use cases when ad hoc request comes, right? Somebody is asking you some data which you have not stored based on some indexes, or for which you have not created index, and you still have to satisfy that answer. Maybe you will use global secondary indexes in that case. But common patterns, you would address them through local secondary indexes, and you can have up to 5 local secondary indexes, nothing beyond it. And the thing, they can only be created and deleted at the table time. You cannot separately go ahead and modify them. So be thorough with what you want to plan for your local secondary indexes, right? So I hope this thing is clear and you have better understanding of how indexes work and why we need it. We would talk about more settings of DynamoDB related to its performance, throughput, and maybe some features like DynamoDB stream and then TTL values. So that is coming. Let me stop here and I'll speak to you into the next section. Thank you. Hopefully by now you have a better understanding of how DynamoDB works and the different aspect of DynamoDB indexes and primary key. Now we will focus on read-write capacity. This read-write capacity plays a significant role in the price of the DynamoDB. So how much we are going to pay for this particular service would depend largely on read-write capacity in most cases. The other factor which would affect the price obviously would be the storage you consume into DynamoDB table. But DynamoDB table work little differently in terms of performance. Here the performance is allocated in form of read and write capacity unit. So I'll talk about what is this read and write capacity unit is and why I would be interested to know detail about that. Now, in a traditional world, when you have a relational database running, that relational database would be running on a virtual or physical server, whatever the form is. That server would have some CPU and memory associated, and once you run your database engine on top of that and create table, the performance is mostly driven by the server we are using behind the scene. How much CPU it has, how much RAM it has, how much disk space is associated with it. That would control the performance my table at the top can give me. Everything is being boiled down to the physical or virtual infrastructure we provide. Right. If we need to have more performance, we would keep on adding more CPU. If we need more memory, we would keep on adding more memory here directly into the server, and that would be reflecting into a table. Now, on that database engine, if you have multiple tables running or multiple databases, then the performance is allocated to all of them when you are adding capacity in the physical server or virtual server, but you are not able to control in most cases capacity at the table level, performance at the table level, but that is not problematic with DynamoDB, as DynamoDB is a managed service. What we can do, we can just host our tables on DynamoDB and all the performance would be configured at the table level. We do not have to worry about the backend CPU and memory. In fact, there is no way to configure CPU or memory for DynamoDB. The only way you configure performance setting is through read capacity unit and write capacity unit. So performance is controlled by RCU, which stand for read capacity unit, and by WCU, which stand for write capacity unit. So what this RCU and WCU is, what is the measurement for these RCU and WCU? Let's talk about that. So one RCU is a one strongly consistent read per second or two eventual consistent read per second for an item up to 4 KB in size. So when DynamoDB is performing a read, you are basically reading a 4 KB size data. It could be if a data is bigger, let's say data is 6 KB, that time we have to perform two read operation for that data. One would be of 4 KB and another would be having 2 KB. So that is two read operations happening there. Right. There is no partial read. So if I'm using this kind of 6 KB items to store and I'm reading that 6 KB item, basically I am consuming 2 RCU here, read capacity unit. Now what is the difference between strongly consistent read and eventual consistent read? You know that difference, we already discussed that, because when we are performing a strong read, what is happening behind the scene, that it has to identify a leader and then perform the read operation from that leader. That's what happens when you are using a strong read. When you are using a eventual read, which is your default, that time only operation has to be performed is a read operation. No need to look for leader. So that's why it would be faster. So if I have configured my table for 5 RCU, in that 5 RCU, I would be able to perform 5 strong read, and in that same RCU, I would be able to perform 2 times of 5, which will be 10 eventual read. So whatever RCU configure, you would be able to perform double of that in an eventual read fashion, and the same number would be used for your strong read. That's how this capacity is configured, and I'll show you that into a console in a minute. Once it comes to WCU, which is write capacity unit, a write is considered for 1 write per second for an item up to 1 KB into size. And with write, there is no confusion about strong and eventual. Everything is a strong or a consistent write. So 1 WCU is made up of 1 KB in size, 1 write per second, and this whole thing is available into DynamoDB console to identify. So I'm going to console, and here we would be creating a table. I don't need to create the whole table, but I'll just give you basic idea that how it would look like. So let's say I'm going and creating all books table, and then I have a key to give. Let's say just call it uh, title of the book, and here is my setting. Now, if I go with default setting, every DynamoDB table by default gets 5 RCU and 5 WCU configured, and obviously it is editable after creation, no problem at all on that. So I would go ahead and modify that to a different setting. For that, I would select a customized setting. So when I'm selecting customized, I have option to select the table class. This has majority of pricing information detail. Like if I'm selecting DynamoDB standard, this is mostly a general purpose table which I am using data on a very regular basis, and that is where I would be paying for store frequently accessed data and throughput, which is read and write, as the dominant table cost. But in case you have some data which you do not access frequently, you may want to keep it into DynamoDB standard infrequent access tier, where the cost is more dominant by the storage you use, and this was relatively is a new feature. Right now I am interested into a capacity calculator here, and here I could perform some verification of how much capacity I should configure depending on the size of the data and how many reads I want to perform, how many of them eventual, how many of them strong. So let's say my requirement is I have an application which requires 4 KB of item to read, and we plan to read up to 10 items per second, and I want that to have a strongly consistent read. So that is reflecting here. I would be needing 10 read capacity unit for 10 items of 4 KB in size. If I say 5 KB in size, that would double my read capacity unit if I have to still perform 10 read per second, because now I am consuming 2 read capacity unit for every item. One capacity unit will read 4 KB data and remaining 1 KB. And if I say, okay, let me clear it, make it simpler again, 4. And now I say I don't want strong consistency, but I want eventual consistency. So same 10 read per second for a 4 KB item would be delivered to me into a 5 RCU configuration only. So I'm just providing the half RCU configuration, and I would still be able to perform 10 read per second, but in an eventual format. Right, so hopefully this thing is clear. And it also tells me the estimated cost based on what I configured in this case. Then we have other option here called transactional. So transactions are supported by DynamoDB, where you could have a whole transaction like a money transfer happening from one account to another account, or a sale or purchase happening for a specific product. So those transactions are also supported by DynamoDB. Right now, I am interested also to know the write capacity. Let's say my item is also, when I write, it is going to be 1 KB only, and I want to, item size is 4 KB, but I want to perform, let's say, 10 write. So if I'm performing 10 write, in a standard fashion, I would be needing 40 write capacity unit. That is 4 into 10. That is the number coming up. If my item was just 1 KB in size, I would be needing 10 capacity unit, and this would be my cost associated. So this is my capacity calculator, very handy tool to estimate the prices. The actual charges may still be varying, but this is giving you a good idea of how much you may end up paying when you start using DynamoDB tables. Right. Below that, we have option to select capacity mode or capacity setting. There are two settings available. One is called on demand and another one is called provision. I'll talk about that, but let me first go to the slide and give you some detail, and then we will discuss about how these modes would be affecting you. So I'm talking about DynamoDB capacity mode. We have two capacity mode, read, write capacity mode. What are they? Let me explain that. You may have a provision mode or you could have a on demand mode. Provision is I set a value. I say, hey DynamoDB table, give me 10 or let's say 40 RCU every time that I provisioned for. I have already asked, in a way you could think of like it's an upfront kind of reservation. We have asked DynamoDB to keep for us. So that is called my provision mode. And then second mode we have here is a on demand mode. Whatever request comes in, DynamoDB would be able to handle that without you worrying about capacity planning. In provision mode, obviously I have to decide on what capacity I plan to use, and based on that I would be configuring provision mode values. But in on-demand mode, I have nothing to worry about. Just select on demand and DynamoDB would take care of scaling up and down depending on the request which is coming up. But is both of them have their own challenges, plus and minuses, so we have to be very careful in what we select. But the good part is this can be changed over the time if you need to. Maybe you initially started with on demand or provision and then you want to change it later. No problem at all on that, and you can configure that change to happen also in an automated fashion, because at the end everything is an API call in AWS. Right. So what these modes are. Provision mode says we will provision the capacity to run at a specific limit. We would set up what we are looking for, and that would be provisioned for us, that would be kept ready for us. That is my provision mode. Second one here is on demand, which says no limit scaling, serving thousands of requests per second without capacity planning. So that is my on demand mode, and if you see this graph, I have put that as a straight line, and this one is a zigzag pattern which may change over a period of time. Charges, how you pay. In a provision mode, you pay for what you configured into your application. What I mean by that, so if you have said that, hey, I want to have a specific number of RC or WC always available, you would be paying for that. So here you pay for provision capacity whether you use it or not. Think like you booked a hotel room which is non-cancelable. You booked it, whether you stayed or not, you have to pay. You booked 10 room, you stayed in only on 2 rooms, or your guest arrived only for 2 rooms, 8 are still there, but you are still paying for it. That is your provision mode. So you pay for provision capacity whether you use it or not. So be aware about what you would pay. Then you may be thinking, then why somebody would use it? Idea is that this is giving you a peace of mind, that this is giving you a specific amount to pay every month. You are not surprised by change into the cost of DynamoDB table. So maybe your application or a budget for DynamoDB table is, let's say, amount X. If you are using provision, it will not go beyond that X amount, whatever you want to achieve. So that's why it is giving me little peace of mind in terms of how much I may end up paying for DynamoDB. Whereas in on-demand mode, what happens, I am paying for read and write we perform. So yes, if we perform one read, we will pay only for that. Right, give me a minute. One read, we will pay only for that. And if we perform 10,000 read, we would be paying for that too. So yes, your bill would be always variable, but in case of provision, it is always going to be a almost fixed amount. So on demand may work well, but what if you were expecting 100 requests to come in? Maybe due to some fault or error, or maybe due to some of the misconfiguration, or maybe some hacking, you have lot of requests coming to your table. And now you are liable to pay for that because you configured it to be an on-demand mode. So that is what you have to be aware. Maybe you should put some alerts into picture. You should set up some type of mechanism to identify if that billing goes beyond a specific threshold. Maybe I want to get notified about it. So that can be done. The benefit of provision mode is that you can control the cost, as I said, and if you know what you are looking for, you can ask for DynamoDB capacity reservation. Same like you do EC2 reservation, you could also do capacity reservation for DynamoDB table, and that would obviously will be giving you better pricing in terms of your monthly billing. So that is your provision mode. On the on-demand mode, the benefit is you can instantly accommodate your workload as the traffic ramps up or down. You don't have to worry. You just say I want to have a on-demand mode and everything will be taken care by system. Now, if you are thinking like if I configured, let's say, provision mode for 50 RCU or whatever, and what if the request keeps on coming and they request 60 RCU? What happens in this case? In this case, DynamoDB would go through throttling. So throttling is happening because we do not have sufficient capacity planned and there are more requests coming in. Like if you have a specific place where number of people can only enter, and if the people waiting are more, then obviously there will be throttling. They have to wait till that the space is available and they can come in, and you may have to implement that retry type of logic in your own application. So throttling may happen in provision mode if your requests are going beyond what you configured for your application, right? So let me go to console and let's see this information into action. So if I say, hey, I want to go with on demand, I don't have to worry at all. Simplify billing by paying for actual read and write your application perform. That is my on demand mode. Now, when this on demand would be better and when this provision mode would be better, let's see that. So provision is suitable if you have a steady state and a predictable traffic. Right. If you know what your traffic pattern is, maybe every morning you have less requirement, every afternoon you have high requirement, evening again less requirement. So there is a pattern there. There is a steady state of the traffic which you are expecting on a day-to-day basis. That time provision mode can be a better choice for you. On-demand mode, on the other hand, is good when you have a random and unpredictable traffic. Right. So on demand, let's say I have launched a marketing campaign and I'm not sure how many of the users would be using my application. I need to be ready for whatever surge or spike I get. On demand is better. But if I know and I want to be budgeted for the price I am paying, I would probably go ahead with my steady state. So if I'm, let's say, running a QA environment on a continuous basis, and then I may put a provision mode on that, even if tens and thousands of tests run on that particular table, I won't be paying beyond a specific number. Let it throttle. Maybe that is not a critical workload for my application. So that's why you have to decide on what will work best for you. When I configure provision mode, then I have to specify some more setting, which is called your floor and ceiling setting. Here in this case, we configure with provision mode, which is manage and optimize your cost by allocating read write. In provision, we have a feature which is called auto scaling. I could say, no, I don't want to do auto scaling at all. So see what I did here. I said provision plus auto scaling off. That means I would pay for 5 read and 5 write come what may, and I'm not going to change my scale, change my read write capacity based on whatever request comes in. So that is no auto scaling, just a flat 5 RCU, 5 WCU configured. But with provision, you can again give a minimum value and a maximum value you are planning for. So I could say, hey, I want to use provision. I know what is my minimum and maximum value, and let me dwell between them. Let me shift from one minimum to another maximum, and then, minimum to maximum, and adjust my capacity based on that, but keep some buffer available for me. Right. So that time I could go ahead and configure auto scaling, and in auto scaling I could say minimum capacity I want to have, let's say, is 1, maximum I want to use 10, and target I am planning is 70. So DynamoDB would always keep 30% room for growth, not beyond 10, not below 1. So that is my target utilization, which I could configure, and that can be done for both read and write. You specify minimum value, you specify maximum value, and you put a target utilization you most of the time expect to use. Right, and that 30% is a ceiling available, and DynamoDB would adjust that till it reaches to maximum capacity unit. So it's a kind of a best for way when you have a pattern. Let's say sometime your traffic is low and on regular time it spikes and then comes back. So it would keep on adding capacity up to it reaches to maximum on its own. right? But you are still within the maximum limit, so you won't get any surprises in your pricing or in your monthly bill. So I could configure these settings also, should not be a problem. Here it is called minimum capacity and maximum capacity. I plan to call these as steady state, and I call it a floor and ceiling. So I could configure a floor and a ceiling. It can be set up using auto scaling in provision mode. On demand, you can scale to 0, no ceiling. Whatever request comes in, we should be able to fulfill by the backend services DynamoDB provide. So that's how easy it is, and you can change this setting even after table creation. So maybe when you do not know what type of your workload access pattern is, you are just starting a new application, maybe better to start with on demand, and once you have a fair idea of what actual utilization may look like, may go for provision mode, because provision mode will also help you to do capacity reservation, which will eventually save some dollars for you. So that would be a better approach if you want to. So decide what works well for you. Maybe it would require little type of back and forth before you actually decide on what you want, and maybe you started the provisioned, kept it like that, launching a new marketing campaign, unpredictable traffic pattern coming up, go to on demand should not be a problem. So I hope you have a better understanding on the DynamoDB capacity mode. Expect some question on these, that what time on demand would be better and what time your provision mode would be better. So I would say this line is important. So if you have steady state and predictable traffic, go for provision. If you have random and unpredictable traffic, go for on demand mode. So I hope you are learning something new, and I'll talk to you into the next section. Thank you. Let me share some additional resources for your certification journey or your AWS learning. I have compiled all these resources on one single website called analogiescloud.com, and I have put together all the resources which I have created here. So if you go to this website, you would find YouTube channel link. In this YouTube channel link, you can find videos. I have not uploaded a lot of videos, but if you are learning something, my suggestion would be to go with playlist. Like there is a playlist for core service storage. I will add more cloud computing basics. So you could pick up a playlist and go through understanding these topics. Second resource you could use is Udemy trainings. So I published some trainings so far, like 3 of them as of now: storage in cloud, IAM easy explanation, and databases in cloud. So you could check those resources also. Other resource I have put together is a book which I authored with some other technical trainers in AWS, which is Cloud Computing Concept and Tech Analogies. So we tried to explain this technical concept in an analogy format, like there is a group of people who are hired into a company and they want to migrate to cloud, how the journey would look like, what concept they have to understand, how they would navigate from technical challenges, and this is written into a conversational format. So you will find characters who are talking to each other, and while they are talking, they are explaining technology and understanding the things. Next is the service summary cards. This book is available. You could get it from Amazon. It is paperback as well as Kindle format, and this is where I have created all these single pages summary of every AWS component or every AWS service. These are focused on certification. So like this is for solution architect, and here you will find detail about individual certification, what are the services covered, what is expected in that, and all of this put together into one single page. So I call them service summary cards. You could check this book here. This book Cloud Concept will be available by April 28th. So depend on when you are watching it. This book would be made available by April 28th, and that would be again Kindle edition as well as paperback edition. Now, apart from that, I have also put together a drag and drop exercise. So in case you want to start building diagrams without creating things in actual AWS account, so you could check your learning by using this drag and drop exercise. Here like a reference architecture is there, and on the left you would find that what service would come into, like first is and dash distribution to provide a caching layer to reduce the cost of image processing and the latency of subsequent image delivery. So this is a serverless image handler architecture. That is where we will be selecting which service would fit in. So I think CloudFront would be best service in this case, because we are looking for caching of delivery. We want to put subsequent images directly from cache, so this could be one service. Similarly, I could keep on adding more component on it, and then I could validate whether I have selected everything right or not by clicking on submit, and it will tell you that which component I selected, that was right, but here I selected DynamoDB, the answer should be S3 in this particular case. And if you want to get the whole detail of this diagram, this is the reference architecture from which I have created this drag and drop exercise. So it could be a good reinforcement of your learning. You would also see about interaction with the other AWS services. So currently I have 5 exercises here. Probably I will add more as the time goes by. Another resource which can be also useful is BESA. We call it Become a Solution Architect. This is a program I run with my colleagues in AWS. This is a free program. This is where we train people in technical as well as behavioral skills on becoming a solution architect. So this is agenda for batch number 3. We have gone through all these technical concepts like a technical track, then we run some specialist tracks also, and we talk about hands-on activities also. So we divided this program into 2 sections. One is technical track and second is behavioral track. Behavioral track will be starting for week 9 to week 12, and so far we have gone through some of the speakers and we are planning to run more sessions like this. And we publish these videos in an additional resource section. So we live broadcast on Twitch every Saturday, and afterward those broadcasts are put on YouTube, and we put this kind of resources so that you could learn more. Like here is a recording, here is the PDF of the slide I presented, here is my hands-on workshop we discuss about, and additional resources. All of us learn differently. Some people prefer reading, some prefer watching, some prefer practicing. So we try to incorporate similar type of resources for every session we deliver. So check that program also. We would be opening up registration soon. The last resource I have I have put together the service summary card in a little more graphical format rather than black and white in a PDF way. So you could go ahead and download these PDF. Like these are some services which I published free to download, and that will be giving you a 1-page summary of a service. I tried to cover 7 W questions on the service. What is the service, why, when, where it is running, who manages the service, how it works, how much the cost would be. So instead of going through multiple documentation, you could just check everything into one single page. This will be containing basic information and important information about a service. So these are some of the additional resources which could help you in your cloud journey. So I wish you all the best, and I'll keep on adding more resources in the future on this particular website. Thank you.